Hi everyone, thank you for joining our fireside chat on software-defined vehicles. My name is Bertrand Boisseau. I'm currently in sunny London. I am in charge of automotive for Canonical, so I get to define the whole product strategy for our big portfolio of products. I started working in automotive almost 15 years today, starting in the infotainment side of things, so the embedded devices, the embedded software in vehicles, worked on the navigation elements and on connected services. Then I moved to the cloud part of the story, so the vehicle backend, and up to the monetization of connected services. Today, I'm very lucky to be joined by two super guests, super experts, Jens and Loic. So Jens from Elektrobit. Hi Jens, how are you?
I am fine, thank you very much. My name is Jens Petersohn. I'm currently working at Elektrobit as the head of the product management group for HPC OS. Actually, I started my career a long time ago as a physicist. I'm an astrophysicist. I worked for 2 years at NASA, and then I moved on to work for a fairly major supercomputer manufacturer, after which, around 2006, I got back into the automobile business. At that point, I started my employment at Continental, where I was working in the ADAS group in Germany, up until about 2018 when I joined Elektrobit.
Thank you, Jens. It's great to have you. And we have Loic, my dear colleague. Hi, Loic. How are you?
Thanks for having me, Bertrand. I'm great. For the audience, a little bit about myself. So I work in partner engineering at Canonical. I've been working all my life in open source, generally on commons, starting with multimedia, with VideoLAN client, FFmpeg, and later on working on GNOME for Debian and Ubuntu. And then I was fortunate to be part of the bootstrapping of Linaro. And at Canonical in general, I work on embedded, on IoT, on the mobile editions of Ubuntu. And more recently, partner engineering, what we do is we work with partners of Canonical that want to build an optimized version of Ubuntu for their use cases. So typically silicon vendors and of course Elektrobit.
Thank you, Loic. It's great to have you as well. So let's dive in. We're hearing a lot of discussions around SDVs, so software-defined vehicles, but depending on who you ask, you're not going to have the same definition. So I want to ask you, Jens, how do you define software-defined vehicles?
So from the perspective of course, the industry, the automobile industry, there's multiple perspectives, obviously. But from the perspective of the automobile industry, the primary thing that, of course, it implies is that you're changing the way you are, the life cycle of the software, the way you're developing it and how you're going to deliver it. Classically, of course, the automobile manufacturer commissioned usually tier ones to provide the software as part of single ECUs. We call them single function ECUs. You have many of them in a car, 40 or 50 in some cases. And that software was developed by the tier one, delivered to the OEM, which then connected it together into their EE architecture, the electrical and electronic architecture, right, to set up the vehicle. And that was done specifically for a particular product line, for a particular car line. And it was then, once it was shipped, it largely was left untouched from that point on, unless there was a major recall. Right. So that's now with SDV, of course, we're moving into an era where the software development is going to be loosened from this life cycle of the actual physical car. You're going to have software development occur continuously, even after potentially vehicles already have been delivered in the field. And you will also broaden the base. You will start developing software as a software line and deliver it to particular product lines, cars, on a point basis as the car is then put into production.
Right. So Loic, how does that resonate with you, considering your past experience?
So I've seen like this trend towards like software-defined things in multiple industries, and my CEO even gave this famous talk called software-defined everything. But for the automotive industry, I think it has a very specific meaning, and it's kind of like the realization of the size of the software flowing into a car, reaching new scales, right? Like car OEMs are suddenly having a full-blown software strategy, and they're really thinking about the decoupling of the software development from the hardware development. It used to be that you could ship a car with the software when it was basically fulfilling the one function it was supposed to fulfill and was good enough, and then ship it and never touch it. And I think this time is now over. Like software is constantly challenged, evolving, and it's reaching new scales, and there will be innovation even beyond the shipping of the car. And that's what I think is new and what defines software-defined vehicles.
So Jens, how are the OEMs dealing with the SDV question?
There's still a lot of uncertainty when it comes to the OEMs, and they're trying to feel their way out how to do this. Obviously, everything that we talked about so far focuses on a large shift in the way things are done, and no OEM will want to do this completely on their own. for a very simple reason. It adds a ton of cost and complexity. Plus, you want to, of course, establish a certain amount of compatibility with the rest of the industry. So we see a shift towards consortia, groups forming to start defining out some of the technologies behind SDV. And we see two big ones currently. It's Covesa that has come up, and of course Eclipse, but there are also others. But at the CES 2024, they have all announced that they will now start cooperating and start pushing for a more common vision on this. This is going to help, I think, the industry tremendously in moving faster towards an SDV future than it has been possible in the past.
Right, consolidating the different approaches.
Consolidating the different approaches, defining, because each of them have also worked on different angles to the question. So putting it all together into a more coherent story is going to help everybody in the end.
Right, so for the OEM, the manufacturer, and the tier ones, there's a decorrelation of the hardware lifecycle and the software development lifecycle. But what exactly does that imply for the customer? If I'm the end user, does that change anything for me? Yes.
So many people think it will be like the smartphone. So you have a blank slate where you can download software and completely change the way it operates. It's not going to be nearly that simple because, of course, you are dealing with a 2-ton projectile that can kill people. In reality, however, there will be much more access for the most important part, of course, being bug fixes, because we've all had cars where some feature never quite worked right. So that will be one area where there will be a direct and immediate benefit, but also customization. The entire experience of the car will be able to be much more personal than it was before. So you can put more software, you can theme your car, you can put all sorts of features. Whether or not that's going to be autonomous driving, for example, people envision autonomous driving to be a downloadable feature. That remains to be seen. There are a lot of technical hurdles to make something like that happen. But it will still nonetheless give you a car that you can customize much more like your smartphone. You can put themes on it. You can add additional software for navigation, for integration of smartphone features. All of that will become available.
And what are your thoughts?
Yeah, that's a very good one. I think what's changing is we used to be in a world where you were choosing the hardware, building software to go with it, and shipping it. And now you are kind of like decoupling the layers. I had this funny parallel with like the networking world, like data center networking, where in the past maybe you would get like your networking gear from Cisco. So the hardware was built by Cisco, the operating system was built by Cisco, the application was built by Cisco, and it was like ticking all the boxes, single vendor, maybe single throat to choke, as people like to say. But in the automobile world, we're starting to see like these layers emerging where you want like a variety of hardware to be supported. You want a general purpose operating system that can fulfill multiple needs and different functions inside the car. And of course, you'll have a rich application ecosystem so that you can mix and match and maybe like write an application and run it on multiple ECUs so that you can have like software vendors offering their software solutions inside the car. And that thing is new. It's this decoupling of the layers.
Right, so at the end of the day, the customer hopefully will get more features throughout the life cycle of this car, right? But also, I'm guessing, because we mentioned cybersecurity, I'm guessing with more cybersecurity patches, so CVE patches, right? Is that part of the pillars of SDVs as well, Jens?
Yes, that of course will play a major role. One of the key things, and Loic already alluded to this, is the fact that you are in fact decoupling the way that software is built, it's delivered, and you're also changing your entire strategy, because in the past you built a software into a particular ECU, you built that function into the ECU, and that software was fairly specialized. And we say it was a bespoke software, it was specifically designed for that particular application. Now, because you want to introduce more flexibility, of course, it means that you're going to use more generic hardware and especially more generic software platforms to host that new functionality. Mm-hmm. You're developing the functionality and you're going to source, usually, if you're the OEM, the platform, the software platform you're going to run that function on. And when you do that, you need to also consider, because it's now much more generic software that a lot more people use out there, is much more easily accessible, because generally speaking, the public did not have access to the software in an ECU, but it's much more accessible. You also need to consider it's going to face more of the same types of exposures that you see in other industries, be it the IT industry or any other industry that has this type of strategy. So as you move towards this type of development setup, as you do already have in many other industries, you're going to also face the same issue. One of the key ones, of course, is cybersecurity. cybersecurity is a big issue in almost every industry. And this will also be in the automotive space, and especially with cars becoming more and more connected, the potential ways you can get into the car, not only locally by hooking up to a diagnostic connector, but also remotely potentially, or with over-the-air features. And you need to consider all of those things. So yes, cybersecurity and rolling out regular updates to address vulnerabilities will become very much a fact of life in this industry as well.
Right. So how did other industries face this challenge, Loic?
So I think it's a great time to talk about cybersecurity. We literally faced with the highest level of threats that we've ever seen. And the threats are becoming more sophisticated, but they're also becoming easier to consume, right? I feel like attacking a system is now something that the general developer can do. You will find tools online, and it's becoming commonplace to attack systems. In recent events, tentatives to attack automotive ECUs, and actually it's fairly easy to pierce through software that was written a few years ago and to realize, it's really fairly easy to break into. So we saw that in other industries as well, and especially in a time of, I'm sorry to say, but war in the world, we see cybersecurity threats escalating and being much stronger, and suddenly a fleet of vehicles that is connected, as Jens was saying, that is online, literally on the internet, that is an interesting target, right? You could actually literally penetrate cars and maybe transform them into listening devices or stop them on a highway, right? We've seen attacks like that, theoretical attacks, but why not actually put them in practice, right? So I think it's something that has affected other industries, data centers and embedded computers, industrial sector. They've been preparing for that for years and have been putting cybersecurity measures in place. And of course, the feature number one is updating your software, right? It's kind of the basics of the basics. OTA, make sure you have an OTA mechanism, but also make sure you do produce updates regularly, that you deploy them to the field frequently. And you have to keep exercising that pipeline of software all the time. And then, of course, you want a strong security architecture, and you will want to model your threats and think about the specifics of your car and how to deal with the specific threats. And that's no different than other industries, really. It's just that the automotive industry in the past used to be a bit more protected, but now it's cracked wide open through this telemetry systems and vehicle to anything's connections. Suddenly, you're directly faced with the threats.
Right. Interesting. So we're also hearing a lot about the UNEC 155 regulation based on the ISO 20434 standard. Will this regulation help with the use cases, the risks that Loic mentioned? Yes?
Yes, it will, because it does mandate the type certificate holder, usually the OEM that manufactures the car, to take certain precautions. Now, of course, as Loic correctly said, we're coming from an industry that is not used at all to doing this in the past. And so they need a helping hand, and the regulations intend to do that. But one thing to keep in mind with these regulations, they are very top-level guidelines, right? They don't actually specify in detail what you need to do. They just mandate that certain properties need to be achieved. And the Regulation 155 that we've been talking about, part of this UNECE body of standards, is actually a very interesting one because it, unlike almost all the other UNECE regulations, actually regulates the manufacturer of the car, the type certificate holder, and not the vehicle itself. Classically, UNECE regulations told you how the brakes need to perform, how the steering needs to perform, what type of fuel economy you need to achieve, and all of these things. It was very specific to the object itself. This regulation is quite a bit different because now it's a regulation that governs how the manufacturer reacts to certain things and what they need to do in order to prepare for this new world of software, right?
Interesting.
Jens, may I ask, do you think this compliance is actually something that might affect time to market of the vehicles trying to go into the market right now that are already in the market?
Yeah, absolutely. Because of course, the other part, aside from having a management process where you manage cybersecurity, is the other one is doing a proper security architecture. It's called a TARA in terms of the ISO 21434, which is sort of the codification of the UNECE regulations. And it mandates that you do a threat and risk analysis, and from that derive a architecture that guards as much as it can against potential cybersecurity risks. You already said that earlier. There is a formal way of phrasing that, whereas a formal requirement for that within now these new ISO standards that mandate these cybersecurity processes in detail, something the UN regulation does not actually do. And within that, of course, there's a lot more effort you need to put in before you can ever hit the road, because you now need to think, how do I protect my system the system being the car and all the infrastructure around it, from potential cybersecurity threats. Which is also, of course, potentially bringing new players into the field. There are no firms, companies out there that focus specifically on providing that type of service to OEMs or tier ones to guard against or analyze and build guards against potential threats.
So we've even heard recently a major OEM take off one of their key vehicles from the market, right? Maybe, do we believe that open source software could prevent or could help these OEMs from dealing with such level of regulations and complexity? Luke, what do you think?
Yeah, I actually think it's funny you bring open source in that picture. So I think it's clear to the industry and many industries now that open source has basically won, right? Like open source is everywhere in massive numbers. It's solving like so many critical business use cases, so many like software problems for so many companies. I think like every single industry has now massively adopted open source. It brings its challenges, right? You suddenly have to deal with software from unknown provenance, right? Like it's coming from everywhere, developed in lots of different ways. And you're trying to leverage this, like tap into this richness of open source while trying to preserve the quality management semantics and the security management semantics of like delivering serious products into the world, right? Like potentially life-threatening devices, right? But you're trying to manage this at a large scale while allowing developers to innovate fast and deliver new functions, right? And I think open source is great at that. Like open source is this bubbling world, and we don't necessarily realize that, but I think we can say we live in an age of cathedrals where we're really building massive amounts of software, which the eyes cannot really even comprehend, but the amounts of lines of code in a typical car nowadays, it's in the hundreds of millions of lines of code, right? And in a complex car, if you sum up the lines of code running on the different computers inside your car, it's massively complex. And most of them are open source. And I think open source serves a major function in demonstrating your cybersecurity architecture, in being transparent and demonstrating that, yes, indeed, this is secure. Like there is no security through obscurity. We all know that.
Thank you, Loïc. Super interesting. So, Jens, how is open source software considered today by the automotive industry, and can open source help with the industry's needs?
Yes, of course it can. Trust, of course, being a very big factor, right? That's one of the big plus points of open source. You can inspect what you're using. There are, of course, a couple of issues that you need to consider that are pretty specific to the auto industry. It's the one consumer product with safety requirements that has the longest life cycle. So because of some of those additional requirements, particularly safety, but also in general, any functionality that is ruled by those previously mentioned UN ECE regulations, you cannot just change that functionality once the car's been put in the field, because it may end up invalidating the type certificate.
Right.
This is, of course, a scenario that no OEM wishes to have, because revalidating this, called sometimes homologation in the industry, is a very expensive undertaking, and you don't want to do that for whatever reason that doesn't actually add any real value. So from that perspective, there are additional constraints you must consider when using software that has a frequent update cycle. Now, open source being, of course, open source, it has very frequent feature updates, very short update cycles. It is a very dynamic and evolving system. But that can in itself present a problem, because now you've got vehicles in the field that have a type certification, and they are running some functionality that is relevant to that certification. In that particular case, you cannot just swap out the operating system with one that brings a completely new set of functionality with it, or enhanced functionality, because it may change the properties of the car, and those properties are part of the certification. And so from that perspective, that's a special case you must consider. And of course, it's also one of the dichotomies that OEMs are currently trying to see how they can solve this, is how do I handle the question of updates and bringing new features to a car on an existing platform versus rolling out completely new platforms without creating a divergence of different softwares that you need to maintain. Right. And that is one of the major challenges you are facing that's pretty specific to the auto industry.
Loïc, what do you think about that?
So it's great. Like right now, we're seeing this explosion of automotive OEMs, each of them creating lots of new models, like innovating in lots of crazy ways. In every single car now, there's more ECUs every year. I heard like the number of ECUs is doubling every year, and since last 4 years, it's been doubling every year, 2 times more ECUs, 2 times more ECUs every single year, which is a crazy exponential growth to go into. So more systems into each car, each of the systems is becoming increasingly more complex, like bringing Linux into the picture, a full-blown set of like middlewares and applications running. And so that creates this massive challenge of a software explosion, right? So I think it's a great moment to reflect on how do you do software at scale inside your car. If you're a car OEM, how do you actually manage to do all of that fast while maintaining your cost low? And that's why I think open source and platforming on operating systems such as Ubuntu is a great way to address the scale of the problem. Would you say like cost and time to market are important to automotive OEMs in that space?
This is one of the key motivators of the automotive industry. They of course want to have faster product cycles. They want to produce more features in the car. Product cycles used to be pretty slow, and years ago you had 5 years or 6 years between major the updates. Now you want to bring a car every 3 years, every 2 years, and you want to bring new features between those major updates cycles. So absolutely, it is a very important motivator for the industry to address the problem. And of course, just to link back to something else you said, there is also a major shift in the way that cars are designed. And classically, you had, as you had correctly said, many different ECUs in the car, and there has been quite a significant growth. As I said before, it can be 40, 50 or more. There is now a paradigm shift in what we call the electronic and electric architecture, the EE architecture on these cars, to fewer, bigger ECUs. So the first step you're going to see in this, it's frequently called the domain ECU, which starts consolidate some functions, usually within a functional domain, into one ECU. But beyond that, you start to have newer architectures that even bring even larger scale things together. The next major step is called the zonal architecture. In the zonal architecture, you start integrating a lot of functions in a core set of ECUs, 2 or 4, and have several around the periphery that then implement the interface to the rest of the car. This is the next major step, very large reintegration of things, going away from this very distributed network today. And then, of course, the final step, or the one major step beyond that, is what's called the big ECU, or the big brain ECU, that consolidates all into one. Of course, the advantage lies pretty obviously, right? Because now you can change, and this is where the word software-defined vehicle really comes from, because in this architecture, you can now define how functions interact with each other strictly in software. In classical networks, we had all of these different ECUs, 40, 50 of them. You had to design your network, your electrical architecture of the car to accommodate the functions you wanted to have. So there was a very strict tie-in in the functional architecture and the electrical architecture. With moving all of these together into fewer, bigger ECUs, you start loosening that tie-in, right? So now your infrastructure, the way you communicate between functions to get the data that you need from A to B, becomes more and more software-defined. So it's now shared memory or virtual networking within an ECU, which you can, of course, redefine even once the car has been shipped. You're no longer tying the car architecture, the electrical architecture, to your functional architecture. It's not frozen in time like it used to be. And it's a major and very important step. Without this particular step, SDV cannot happen.
Is this what we could call like decoupling, disaggregation of the system architecture of each ECU and inside the car's architecture? Is this related to HPC as well?
Yes, and obviously, as you are going to move more functions into single larger ECUs, the word HPC, or high performance computing, becomes very relevant, right? Because you're going to need a lot more compute power to accommodate all of that functionality in that ECU that used to be spread out over many small ECUs. And of course, you want to not only deliver the same functionality as you had before on those many ECUs, you now also want to deliver more functionality. And in the ADAS space, of course, we're now talking about L2+, which is sort of the progenitor, if you will, for autonomous driving. It's essentially the same features without the shift in legal responsibility, but that will require massive additional compute power. So high performance computing, and of course having a development platform, a deployment and development platform that is easy to program, that many developers have gained experience with already, makes this, of course, much easier. So having a mainstream operating system like Linux is a key enabler to make these HPCs reality and delivering all of these additional new features that they could potentially deliver.
It sounds like this new architecture that lets you manage your resources inside the car better, leverage them better, and be a bit more future-proof in the face of like software updates and even like software upgrades over the time of the lifetime of the car, really, right?
That's exactly right. So it's the enabler. And this is one of the key things that is part of this software-defined vehicle revolution. The HPC is an enabler, but having the ability to redefine your communications architecture, having to redefine the way that things interact in the car, strictly in software, is of course the turnkey piece to making all of this possible.
Yeah, it's interesting how like we in other industries we had to build like versions of Ubuntu that would last for like longer and longer periods of time exactly to meet the demands of these industries, and we see the same need in the automotive industry. Like when we started offering Ubuntu for 5 years of like standard security maintenance, and then expanded security maintenance for 5 more years, and then 2 more years, and like we keep extending the duration of LTSs, but people also have the option of like jumping between tracks, right? Like from one Ubuntu version until the next.
Yeah, so we expect the same in the auto industry because, of course, there will be, product lines where the compute power will no longer enable additional features. So you will have product areas branch off and go into maintenance only mode. And in the automotive industry, maintenance still means you have to provide at least 10 years, more akin to 15 years of maintenance for that platform. So you will have those. And of course, you will have newer product lines coming up, newer cars that have more compute capability. They will want to bring, of course, newer versions. So you will have both. And of course, you want to keep the divergence between these as minimal as possible, because otherwise you're going to have a maintenance nightmare. So yes, having a long-term maintenance, and in those which you've in essence archived, those which gone into maintenance only mode, you have to provide the cybersecurity maintenance, everything essentially for the software unchanged. Right? You need to have a very long life cycle on that software maintenance without changing feature content in order to meet those requirements of these main product lines that are no longer undergoing active feature development.
So Louis, can you tell us more how Canonical managed to address the need for long-term support on Linux?
Sure. So Ubuntu is now like a fairly well-established model for releases. Every 6 months, we take a snapshot of all the latest and greatest open source software. We stabilize it, and then we do a release of Ubuntu out of it. And every 2 years, we'll put out like one of this long-term supported version of Ubuntu. And on any of these Ubuntu releases, you can basically subscribe to the level of services you need if you do want like a longer security maintenance period, or if you want like support services. And that's what we generally call like Ubuntu Pro, right? And this offering has been meeting a lot of demand across all the industries. And I think this kind of like foundation, this kind of like TikTok of getting an LTS out every 2 years has been a great building block for other companies to build their products on. I'm curious, is this what led you to Ubuntu as you were considering your foundation for Corbos Linux, Jens?
Yes, absolutely. This was one of the main reasons when we were looking to build our product, EB Corbos Linux, trying to address those needs of the auto industry with an open source solution. We were looking for a really strong partner who had experience and could deliver on this, especially this particular issue of maintenance, in a way that worked for the automobile industry. And Canonical's Ubuntu solution was exactly what we were looking for.
Awesome. And so, yeah, one thing we're trying to do with Ubuntu is because open source keeps changing, keeps evolving, we see new technologies, we even see like new languages, right? Like Rust was not widely used a few years ago, right? And before that it was Golang, and I'm sure there'll be like more languages coming. And we see an explosion, like most things don't get removed. We keep adding layers and layers. It keeps expanding, right? Mm-hmm. And so like to stay relevant, we have to basically integrate more and more open source. And Ubuntu has grown massively in numbers, in duration of its maintenance, the number of open source software we're integrating. But I think it's really responding to what every single industry is currently innovating on. And I see the same innovation acceleration in the automotive industry. So it's a difficult balance. You have to like deliver all of this innovation, but you still want to preserve the quality of the resulting product. So how do you go about like the quality management in Corbos Linux?
So first of all, of course, you already touched on this particular point. A software that's targeted at the auto industry will not include the complete feature set that Ubuntu has today, because that simply A, doesn't make sense in the context, and B, becomes very problematic from your point, from the point of view of the quality management. So there are a number of things you need to do, and already Canonical also does a lot that we use in order to build this argumentation. But a big and important thing is to first of all to be able to justify, right? So the process when you put together a software, the classical engineering software process it's largely all about documenting how you arrived at a particular way of solving a problem. So you do an architecture, you do a design, and so forth. So obviously, this is not something you do to the same extent. In some cases you do, but it's usually not done in the open source community as such. So we need to build an argumentation that the software that we have chosen, that you have chosen, and we have chosen as a result, meets certain quality criteria, is by laying out the quality criteria that we look for. You know, what is this a healthy project, upstream project? Is it fixing its bugs at a regular rate? What's the incident rate of major issues and things like that? So that's the kind of thing. And by properly documenting this, we can already fulfill at least part of the quality management process that pertains to the question of why did I build this software the way I did? So that's one of the major steps. And of course, the other part, which we add primarily as EB, is to have a very detailed, essentially service level agreement, you want to call it that, how things are handled when something does go wrong. You know, the problem resolution management and the way you deal with issues as they occur, and how you roll out fixes for those events when they occur. And that is the second part of this. There are also obviously more parts. If you look at an ASPICE standards, you'll find a lot more parts to it. But to touch on some of the very basics, this is what we do. And we actually, one of the major areas that we are investing in as EB is how to overlay something like a SPICE or ASPICE standard on top of the open source world, and how we can bring those together and still meet the expected quality criteria that the automotive industry has built over the last 40 years or so.
So Loic, what do you think about that?
That really sounds like the best of both worlds. You're kind of like combining the like quality and long-term maintenance of Ubuntu with automotive-specific processes, right? If your automotive OEM wants to work following an ASPICE measured set of processes, and if you want to do ISO 25010 or have like a quality management system or cybersecurity management system, they can work with Elektrobit to basically guarantee they're going to pass certification and meet expectations of certification bodies with Ubuntu-based Corbos Linux.
Absolutely, and that is the thing. And we as an organization, Elektrobit is a large player in the automotive space, especially software. And we have, of course, many decades of experience in this particular area, dealing with the needs and the oddities, let's call them that, of the automotive industry. We don't see ourselves in a position that we know open source. So that's why we were looking for a strong partner who really knows open source. And putting that together in a partnership is what I believe personally, but obviously, as we sit here today, a lot more people have believed is the best way to deliver on that.
So EB Corbos Linux built on Ubuntu is the outcome of this partnership, leveraging the experience in automotive grade software from Elektrobit and the open source software experience from Canonical, right? But what exactly is EB Corbos Linux built on Ubuntu, Jens?
It is, in the first step, of course, an operating system for use in the automotive space, trying to address some, of course, the other issues that we haven't really touched on. For example, size and performance are always very important aspects to software for the embedded use case. It is a software, it's an operating system for specifically the embedded use case. You wouldn't ordinarily want to use it on your desktop computer, but you could if you wanted to. But it really is targeted at that, and it's designed to make the most out of the resources that you have available in the final ECU that it will be running on. But it's much more than that, right? Because ultimately the way that our customer interacts with the software is through the development cycle. Once the software is in the field, the customer really doesn't interact with it, aside from this maintenance question, all that much anymore. So really, we need a strong support for the development cycle. So we need to tie in a lot of new trends that we have only touched on real briefly in the question of SDV, is the move towards a cloud-centric development environment, where you develop software and you test software within the cloud. You enable this by having the same software, ideally the same software that you're running on your ECU then in the end in the car, as available as a platform as well in the cloud for development and testing purposes. And that's the other major area. So we are putting together with this product, those things to enable the embedded space, but also the main add-on compared to a standard desktop targeted Linux distribution is the fact that it enables you to use it as a building block in multiple different places, like a cloud environment, different types of hardware environments. It gives you an abstraction, so the development can occur largely independently of where the software is going to run.
Right. So at some point, still, if we manage to reach a certain level of software abstraction, we still want to have the right level of hardware support, right? So how does that work? How do we work with different silicon platforms?
So sometimes Ubuntu gets hardware support through the mainline Linux kernel, right? Which is the best way. Then it's well written, it's peer reviewed, it has passed a lot of scrutiny, which is amazing, and usually it works great. Like the drivers you get from Linux kernel are usually of like top-notch quality. But very often, new silicon is developed in a branch of the Linux kernel with a BSP that will take some years before it's fully mainline, it's fully upstream, right? And the silicon vendors are going mainline first. They're making real efforts to get their patches in the mainline. But in the meantime, they also work with Canonical to put the support for their silicon directly in Ubuntu to basically reduce the time to market, right? Like be able to sell the silicon and put it in production applications as soon as possible. So Canonical does partner with silicon companies to integrate support for the latest silicon in every single Ubuntu release so that people can build products such as Corbos Linux on top of that silicon support. And indeed, you can leverage this for your cloud-centric development stories. I mean, Ubuntu has these great features of being available on laptops and workstations, but also in containers and, of course, in public clouds. And I would say the trend nowadays is to basically either run a simulator or bring up a VM, an AMI in the cloud that is directly an image of Ubuntu with the tools pre-installed to work on Corbos Linux development. So yeah, it's quite typical to basically create a public cloud image with the tools pre-installed for developers to be able to start immediately. And I want to so you have like a Corbos Linux image with like the Corbos Linux development tools pre-installed?
Yes, we do. As a matter of fact, we recently rolled out an AMI image in the AWS marketplace, which contains EB Corbos Linux, and it will then, of course, in the future contain all the enhancements and developer tools that we're bringing along with the basic operating system image. Yes.
So I can just spin one up like an ARM64 VM, and I can start developing directly on AWS and
yes,
start
it's available as a free public image, so anybody who wishes can certainly start using it for whatever purpose they like. All of our software is available completely in the spirit of open source for free download, including all the source code, and any changes we have made either to existing packages or new developments we have done, we have either upstreamed or alternatively open sourced ourselves. So we very strongly believe in the open source ethos here, and we follow those ideas to the letter.
That's great. It sounds like cloud-centric development is really going to pick up with automotive manufacturers, shifting left and allowing like cost savings.
That's right. That's the primary motivator, because as you start building lots of new complex features, you can't possibly test them all on the road. The expense of doing so would be massive, and of course, time to market is an issue there as well, right? You can only have car fleets of a certain size, and you wouldn't be able to complete the testing in any sort of reasonable time. So everybody in the industry is now looking towards cloud-based, at least partial validation, where you can not only develop and build your software, it's already a time saver because of the greater resources, but especially given these new hardware architectures, ARM-based cloud infrastructure, you can now start also testing your software there, and you can do a lot more in that area before you ever hit a physical car, saving you tons of time and money.
So you both mentioned how potentially dangerous a vehicle could be, right? It's a very heavy object, sometimes more than 2 tons, moving at high speeds, right? So there's a safety side to the story. There's often a misconception between security and safety. Jens, maybe you could explain the difference between the two?
Yeah, so I'll briefly touch on where they're similar, and then I'll talk about the differences. So the similarity comes from the fact that they are both a specific codification of requirements put forth in the previously mentioned UNECE standards or the UNECE regulations. This codification, in essence, turns a very high level, you should do this, into very specific instructions on how to do it. So that's where they're similar. Both are outgrowths of that. One focuses on the cybersecurity. We touched on that before. The other one focuses on safety, the ISO 26262. And it primarily deals with those parts of the car, those components and software elements that actually, if they fail, would endanger either the occupants or perhaps people on the outside of the car. This goes beyond a step beyond what you would consider reliability. Obviously, things breaking on the car or not working properly is not something that anybody wants. But the biggest question is, if that element doesn't work properly, what are the consequences? And that's the big difference. They are also related in as much that, of course, functional safety cannot exist without cybersecurity, because, of course, you lose any and all guarantees of functional safety if somebody hacks the system, because now you're running software that you do not know, potentially. And as a result, there's a lot of cross connects. Functional safety absolutely requires cybersecurity. Functional safety is also an absolute core component for a lot of the features that make a car, that allow you to operate the car, accelerate, slow down, steer, and so forth. Those are all functions that do have safety implications if they malfunction somehow. At minimum, the driver needs to know that they have malfunctioned. Even better, they have some sort of safety mechanism to take over or deliver minimal functionality if the feature no longer operates as designed.
So how will Elektrobit address this functional safety challenge?
So as you know, Linux has already been used quite a bit in the automotive industry, but in the past you were, of course, forced to switch to a proprietary solution if you needed safety features. We intend to change that. We intend to announce upcoming a product that's an add-on to the basic EB Corbos Linux solution, and it will enable you to run software on top of a Linux with safety. So this additional component, the safety feature, will allow you to encapsulate, in essence, your program from the system surrounding it, and will protect the application program from any errors that occur within the system surrounding it. It gives you the best of both worlds. You are running on Linux, you can develop for Linux, you can use many of the features that Linux provides you, but it also gives you the ability to do this in a safety context. It's a truly unique solution. As far as we know, it's the first time anybody has ever done this. It's something that a lot of people have worked in the last 20 years to find a solution for. This is the first time a product coming to market that combines both open source and safety and allows the integrator, the customer, to deliver features on Linux with the appropriate safety.
Thank you both again. So we covered EB Corbos Linux built on Ubuntu and how it can help address the SDV challenges like cybersecurity and functional safety. So if you are facing similar challenges than the ones that we discussed today, get in touch. Thank you for joining and see you next time.